Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is sum of prefix scores of strings. Okay, so the problem statement goes like this. You are given an array of words of size n consisting of non-empty strings. Okay, so a string array is given to us and it will be having entries, non-empty entries in the form of strings, and we define the score of a word as the number of strings uh, in the given words array, which are the prefix of the given word. For example, if the given words array is this, okay, let's take this example to the board and try to understand what is the score of a word. Okay, so let's open the board and take it to the board. So let's say this is the words array and you decided to pick up the word ABC. Okay, so see, what are the prefixes of the word ABC? Okay, or let's take a short word. Let's take AB. Okay, what are prefix of AB? It's A and then AB. Okay, so two prefixes. Okay, and then see, this particular A is appearing in how many of these words as a prefix? Okay, it is appearing here, then here, then here. Okay, so there are three words in which this particular A is appearing. Okay, and AB is appearing as a prefix in how many words? Okay, so this word AB is appearing, okay, as a prefix. Okay, and then here also it's appearing as a prefix, so 2. And if you sum these two, it will become 5. Okay, so the AB is appearing twice, and the string, okay, here the example is taken of AB only. So this AB is appearing twice, so the overall score of AB was 2. Okay, both in AB and ABC. Okay, so these two AB were appearing. Okay, and return an array of size n, where answer, each entry in the answer array is the sum of the scores of every non-empty prefix of the entry that corresponding entry in the words array. Okay, for example, if I want to find the score of this particular one AB, then for all non-empty prefixes of AB, these two were the non-empty prefixes of AB. Okay, A and then AB complete. Okay, you have to find out the score of all those prefixes. So the score of, if we take score as a function which will return you a integer value. Okay, score of A plus score of AB. Okay, this is what you have to do. Okay, for each of the words, and for this corresponding, let's say it was X, for A it was X, then for AB you will be basically taking this value. Okay, let's say this value is Y. Okay, and this entire array, like that, will be your results array. Okay, so this is what you have to return, this array. Okay, so I again repeat, for every word you have to take all the non-empty prefixes, and then once you have taken all the non-empty prefixes, for those prefixes you should be finding the score. Okay, and then adding them, and that will be the total score of that particular word. Okay, sum of scores basically. Okay, of every non-empty prefix of the given word. and return its corresponding value, or add its corresponding value to the answer array at the particular index at which, or the corresponding index in the answers array. Okay, and the note that the string is considered as a prefix of itself. The whole string will be the prefix of itself, as we have done in the case of ab here also. Okay, we were considering ab as the prefix of itself. Okay, so I hope the problem is clear to you. Now before thinking of an approach, let's have a quick look at the constraints. So according to the constraints, the length of this words array will be of order 1000, and each entry will also be of order, length of each entry basically of each string will be of order 1000. Okay, so then each of the words will consist of only lowercase English letters. Okay, and for doing all this in a brute force way, so if you want to first of all generate all the prefixes of every word. Okay, of every word, and then after generating those prefixes, then you will be wanting to somehow collect all the prefixes and of every word, and then have a frequency of it. Okay, so it will not be a very optimal way of doing it. Straight away logic will be to use try. Okay, because it's much efficient, and it's very intuitive also, if you understand what a try is. Okay, basically, let me take the code to the board, and then I will be explaining how the structure of try is. Okay, and how it will be helping us to achieve our result. Okay, and it will you will be able to see that it will make the whole process of finding the score very easy for each of the words. Okay, so let's take the code to the board. So let me take a fresh slide for that. Although I could have explained you the brute force approach, and we could have went into the complexities analysis, but it is a more optimal way, and it will for sure not give you time limit exceeded. Okay, because we will be implementing a complexity of, just for the sake of telling you prior to discussion, we let's say the average size of the words in the words array is len, or length, then, and the number of words is n in the words array, then this order of time complexity and space complexity will be using. Okay, and since both of them were of order 10 raised to power 3, so all over order of 10 raised to power 6 something operations will be required to solve the problem, by the approach that we will be discussing further. And there is a limit of number of operations basically, uh, of 10 raised to power 8 operations. If the number of operations required by your solution to solve the problem is less than this particular limit, then your solution will be getting accepted. So that's how I came to think of this approach. I was knowing what kind of complexities we will be dealing with if we implement try. Okay, and then I think of this approach. Okay, by thinking of this after seeing those constraints. Okay, so anyways, if you are hearing this term for the very first time, this try data structure, a link of an article explaining this data structure will be there in the description box. Please do check that article out and learn more about it. And here we will be using a slightly tweaked version of it. Okay, so please check the link, uh, explore that article, and try to understand what a try is. Only then you should be proceeding further down the solution. Okay, so without further delay, let's take that code to the board. So this is the code. Let's zoom in a little bit. Yeah, I think now it should be fine, and let's get rid of this toolbar and let's begin discussing. Just a second. Yeah, now it should be fine. So what happens in a try is, consider a tree having a node, okay, and this particular node, let's say we are calling try node, okay. Try is basically kind of a tree, you can imagine. So it is having some children, okay. So this try node is having some children. So let's say there are some children and they are like this. In order to get fast access of these children, we are storing them in a array data structure, okay. So we are storing them in a array. So these children will also be try nodes in themselves, okay. Now these children might be having some children of their own, okay. Let's denote some other color, it with some other color, okay. And they will also be stored in a array data structure for fast access, okay. Because we will be dealing with the indices, and indices will give us the value of that particular node right away, okay. So this kind of structure will be there. Now you might ask how it will be helping us to, store a particular word, okay. Let's say the word is ABC, okay. And this is the, let's say, the root of the try data structure, okay. And let's mark the indices of this array: 0, 1, 2 and 3. It will be basically of 26 size. And why I have taken 26 size? Because the hint was there in the constraints. This was another reason that I decided to use try. So I straight away see that only 26 entries are required, and for each node, because lowercase English letters are 26 from A to Z, okay. So each node can have at least 26 characters, and it will not be consuming that much of space, okay. It will be almost constant, okay. So what we will be doing here is, see, we will be visiting this string character by character, okay, or processing this string character by character. Now the first character is A. For every character that we are processing in left to right direction, we will be taking its relative difference with respect to small a, okay, in order to, just for the sake of getting the indices at which we would be liking to do the insertion, okay. So it comes out to be 0, okay. Now in the current node, okay, let's say there is a variable current node, and it is pointing to currently to the root, okay. For the children array of the current node, you will be visiting this particular index, 0th index. So you will be adding your a here, okay. Once you have done that, you will see at which particular node, or which particular child of the current node you have done the insertion, and then you will change the reference, or make the current node variable to point to that particular node, okay. Now your current node will be a, okay. So the next time you will be processing character B and taking its relative difference in order to find that index with A, which will come out to be 1, by the way. Then you will find that particular index in the current node's children's array, okay. Okay, and that will happen to be this particular index, and B will be inserted here. Now again for B you will be doing the same thing, okay. And this time C will be inserted somewhere here, Okay, so here C will be inserted. So see, A, B, C, in a way you have inserted your string. Okay, so see, this is how the insertion will be done. Okay, and you might ask this, how this will be solving us solving the problem of getting score of each prefix. Okay, so for that what we have done here is, we have taken one extra field in the data structure, and that is node frequency. How many time insertion have been done at that particular node. Okay, let's say there was another string a b. Okay, this time again you will insert a here, which is already there by the way. So this time its frequency will be increased from 1 to 2. Okay, a is in a way inserted twice. Then you will come at b, and see b's frequency will be uh, increased to 2 from 1, and c's frequency will stay 1. Okay, and if you want to just find the score of abc, so in that particular case you will simply add these values. Okay, so 2, then plus 2, then plus 1. Okay, so you will get 5. Okay, and for abc, the corresponding result entry will be 5. Okay, so this is what we have to do basically, and it is also, you can see this particular example in the first example also. Okay, if the string was abc, it is having three prefixes ab, a, a, ab and abc. Okay, a was appearing in two strings, ab was appearing in one string, and abc again was appearing, basically a and ab were appearing in two strings. Okay, see, a is appearing here and here, then AB is appearing here and here. So 2 plus 2, and then ABC is appearing only in one string. So in total 5. Okay, so this is how you will be calculating result for a particular word. So for word ABC, you calculated the results just like that. Okay, and this is how this particular uh, try data structure will be helping us to get the result. Okay, and now let's discuss the implementation. We have discussed the approach, so let's clear the board for that. And let's keep this diagram. Okay, let's anyways keep everything. Okay, so see, the very first thing that you will be doing is, firstly you will be wanting to have a root, just like we were having here. Okay, so then once you have that root, you will be inserting the words in the try data structure. Okay, and let's see how we have implemented this insert function. So as we discussed that we will be processing the string that have to be inserted into the try data structure character by character from left to right direction. Okay, this is what we are doing here. Okay, and for each character that we are visiting, we will be trying to find it the index at which it has to be inserted in the current node, and the current node will be starting from the root. Okay, so it is a variable basically of same type try node, and then once you have find out the index, then you will see whether we have done insertion previously or not at this particular index. If we haven't done any insertion, then this value will be null. Okay, because the array is of type try nodes, the children array is of type try nodes, and that's why it will be null. In that case, you will make that particular node. Okay, for this particular character. Okay, once you have made that, then you will increment the frequency, saying that we have used it by one time or increasing its frequency by one. Okay, that particular node basically, if a is being used for the very first time, then you are saying that frequency of a is 1. Okay, and increased by 1 basically, and then your current reference will be changing just like we were doing here. Okay, this particular point. So current reference will be the you know node at which the current, or the index at which the current insertion is being done. Okay, the node represent node at that index. Okay, and this thing will keep continuing till when you are done processing all the characters of the string in left to right fashion. Okay, so once you have done all this, then your that particular word will be inserted into the try data structure. Okay, so this is how you will insert every word in the words array into the try data structure. Okay, once you have done that, then you will start populating your answers array. Okay, whose length will be equal to the length of the words array that is given to you. Okay, let's change color here, and then you will simply call this find score function to find the score of each of the words. Okay, and it is also very similar to this insert function. The only difference is that we will not be doing this null check, because obviously if we have previously inserted that word, it should be there. Okay, all the nodes representing characters of that word. Other than that, instead of incrementing the frequency, we will be now having a score variable, which will have a summation of all the nodes for this particular word. Okay, and once you have got your score, the entire procedure will be similar to the insert function, and then you will simply return the score. Okay, so here also we are uh, accessing the frequency of every character word by uh, every character in the string one by one. Okay, from left to right direction. We are just saying that what is the frequency a is used, then b is used, and then c is used, and summing up all of them, and then returning uh, it as the score. Okay, and then simply basically it's just like that for a b c. You see that a, then ab, and then abc. Okay, so these were, you know the prefixes. Okay, if abc was inserted, then see, if there are two entries in this particular uh, array. So see, AB is seen how many times? A is seen how many times as a prefix? See, A is seen 2 times as a prefix. So 2. AB is seen how many times as a prefix? AB is again seen 2 times. So again 2. Okay. And then AB is seen how many times? ABC is seen how many times as a prefix? Then it's 1. Okay, and it's the same thing if you just add the frequencies of those characters. Okay, so that's what we are doing here, and yeah, that's pretty much it. And once you are having hold of this answers array, you will be simply returning it as your result. Okay, so this is the whole approach, and if we want to have a discussion on complexities, then let's quickly get rid of all these drawings. Okay, let's say the average number of characters in each of these words in the given words array is uh, len. Okay, and there are the size of this whole array is, let's say, n. So the time and space complexities will be len into n, because see, because of the nature of these insert and search operations, uh, this will take the size of key times. Okay, order of size of key. Okay, and there are, let's say, n keys like this, so overall time complexity will be up to this. Okay, similar will be the complexity of find score function. Okay, so this will be the time complexity. And if we want to have a discussion on the space complexity, in worst case there might not be any repetition of any character. Okay, so in that particular case, how many number of characters you are having in the entire words array will be your space complexity, and that will be order of this len into n. Okay, so these will be the complexities. Okay, and this is the whole approach, and this is how we will be thinking of using try, okay, in these kind of scenarios. And I hope you are able to understand, and if you are still having any kind of doubts or any queries in general, then you can ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills, and keep solving more and more problems, and I will be seeing you in the next video. Thank you for watching.